Hi and Assalamualaikum and a very good day to my lecturer Encik Ali Faisal bin Ibrahim. So my name is Adi and today I'm going to present my individual project for CSC 429 Computer Organization and Architecture. The topic of this presentation is Instruction Set Architecture, or people call ISA. In computer architecture, different processors handle instruction in different ways depending on how many memory addresses that can use in a single code of line.
2 hours later.
Okay, today I will focus on two specific types of addressing formats. Okay, for question 1, I will explain how to solve the algebraic equation. I use 3 address instructions. And for question 2, I will explain how to solve this question using 0 address instruction, which relies entirely on a stack system. I will break down the assembly code line by line to show how the logic behind my answer and explain how the CPU processor is. Okay, so now let's move on to question 1. Okay, for this question, I choose the 3 address code format. I will explain how the expression is converted step by step into 3 address instructions. Okay, now this is for question 1. Okay, I choose to present question 1 using 3 format address because it clearly shows how each step of the equation I broken down into spread register like I do in the video. This makes it much easier to understand the core concept of 3 address code. As you can see, what I do is I broke it down to separate courses because of it makes me more understand to do the 3 format address. Okay, now look at the line 1. Okay, first of all, here the opcode, which is mul. Mul is for multiply. The computer multiplies the value in register A by itself, which is give us A2. It then saves this result into our temporary register, which is I declare as register X. So right now, X holds the value of A2, like I'm writing on the whiteboard. Okay, so now for the second step, I multiply A and C. Okay, now we look at the term inside the parenthesis which contains A mul C. We multiply the values of register A and C together. And now we restore into our second temporary register, which is Z. Okay, for line 3, we add B into Z. Okay, since register Z already holds A mul C, we add register B to register Z. Okay, and overwrite the result back into Z like I'm right. Okay, now register Z perfectly represent B plus AC. Okay, now we move to the line 4, which is sub. Now we can solve the entire top part of our fraction, which is the numerator. We need to calculate A2 sub B plus AC. Okay, from our earlier step, register X already holds the A2 and register Z holds B plus AC. So we use the subtract opcode to subtract z from x and store the final answer back into the x. I restore back into the x. Okay. And now what I do is multiply a and d. Next we move to the bottom part of the fraction, which is the denominator a and d. We use the multiply opcode to multiply register a and register d. The project instructions say our final answer must be in register y. So we can directly store the denominator into register y for a y for now. Okay, now we move to the last step, which is divide. Okay, we use the divide opcode, which is div. We take our numerator from register x, okay, and divide it by our denominator, which is inside register y. The final result of the entire equation is saved, of course, directly into register y. So this is the final answer 3 address for question 1. Okay, now it's complete of question 1. Okay, now let's move on to question 2, which is the most challenging part of this assignment. Okay, for this question I choose to do zero address format, and I will explain the conversion process step by step. Okay, now we'll do for zero address. This is for question 2. I chose zero address. Okay, now step first, I push A followed by push B, and then I push C. First I put register A into the stack, then I push B, and then I push C. At this moment, if you look at the stack from bottom on the top, wait, I will draw it for you guys. Okay, when you look at the stack from bottom on the top, the data is arranged A as the bottom, B in the middle, okay, B in the middle, and C at the very top. Okay, now we look at step 3. What I do is I multiply B and C. The CPU pops the two values, which are C and B. Okay, look at the step I draw. And then it multiplies them together to get B multiply C, and push the result back into the stack. Now our stack contains A at the bottom and the product of B multiply C at the top. And now we do sub. This is very critical step where the other metals we call the sub. The CPU pops the top value B multiply C, and then subtract it from the value right underneath, which is A. Okay, this perform the calculation A sub B. So now we will push 2, and then push D, and then push 5. Now we begin solving the fractional part of the equation, which is 2 div D plus 5. I put the constant value 2 into the stack, then I push register D and find the constant value 5. The stack now has our previous calculation at the bottom, followed by 2, then D, and 5 at very top. You can see I will draw it. Okay, now we'll use the add. The add opcode pops the top value, which is 5, and D. It adds them together to create the expression D plus 5 and push it back to the top of the stack. And then next we do divide. Okay. Next we execute the division opcode. The CPU pops the top value, which is D plus 5, and divide the value below it, which is 2. Okay, by this denominator, this gives us result 2 divide D plus 5. And then right now, the stacks contain exactly 2 value. Our first major calculation, A sub B mul C, and our second major calculation, which is 2 divide D plus 5. When we call the add instruction, the CPU pop the value and adds them together and puts the final answer back on the top of the stack, like I noticed. And then pop Z. To finish the program, we use the pop instruction followed by register Z. Okay, this remove the final calculator answer from the top of the stack and write into register Z, satisfying our final constraints. So this is the final answer lah. That concludes on my video presentation of this project. Thank you very much to Encik Arifah Salben Ibrahim, your guidance, and thank you to everyone for watching and have a wonderful day.